Okay, so today we're going to be talking about inequalities. In triangles. Inequalities in triangles. And we're going to start with this theorem that says the measure of an exterior angle of a triangle is greater than is greater than either of its remote interior angles. The measure of an exterior angle of a triangle is greater than either of its remote interior angles. And we talked about this a little bit ago. If this is angle 1 out here, this exterior angle, if we number these angles 1, 2, 3, and 4, what this rule says is that angle 1 is greater than angle 2, and angle 1 is also greater than angle 3. All right, angle 1 was called an exterior angle. It was formed by the extension of a side and its adjacent side. And we said earlier in the year that the measure of angle 1 was equal to the measure of angle 2 plus the measure of angle 3. That an exterior angle was equal to the sum of its remote interior angles. So if angle 1 is equal to the sum of angle 2 and angle 3, well then just by math, it's got to be greater than each of them, doesn't it? Or either of them, as the rule would say. Does that make sense to everybody? Okay. So we're going to list all the angles. That satisfy the condition. We're going to use one drawing to answer two different questions. So we're going to start off with this drawing. And then we're going to add some angles in here. List all the angles that satisfy the condition. In our first condition, measures less than angle 7. So we're looking for the angles that will be less than angle 7. So 7's right down here, isn't it? Come on, highlighter. Okay, do you see angle 7 here? Do you see how it's an exterior angle to two different triangles? All right. It's an exterior angle for this first smaller triangle right here. And then it's an exterior angle for this big triangle. See it? If you can't see it, let me try to help you see it. So it's an exterior angle for this yellow triangle. And then it's also an exterior angle for this green triangle. Which is this really big one around the hole. All right, so we'll start off. Angle 7's got to be greater than, in relation to the yellow triangle. Angle 7's greater than which two? What are its remote interior angles? Good. Angle 4.
Angle 5.
So angle 4 and angle 5. And then it's got to be, doesn't angle 1 have to be smaller than 7? Isn't 1 and a remote interior angle in the green triangle? So we go with angle 1. And then 2 as well, right? Because really, these two combined, these two angles combined would be a remote interior angle for angle 7. So if 7's greater than 4, it's going to be greater than 2 as well, won't it? So we're going to go angle 2 here. Yes, sir.
Wouldn't it be 6 as well? Even though it's not.
Yeah, even though it's not to scale, just by we don't really have a rule that says it is, though. So in this case, we're using the exterior angle inequality theorem. So by that theorem, we could prove that it's, greater than 1, 2, 4, and 5. But unfortunately, we don't have anything else that we can use right there at this time. To say that it's, it's greater than 6, but yeah, unless you did something like, if you subtracted angle 4 and angle 5 from 180, you would get angle 6. But right now, for the rule that we're using, we're going to stick with that right there. All right, so inequalities in an angle in triangles. You guys good with that? And the exterior angle inequality theorem? Okay, so here we go. We're moving on to next rule. If one side of a triangle is longer than another side. Then the angle opposite the longer side is greater than the angle opposite the other side. This will make more sense when we draw a picture. If one side of a triangle is longer, yeah. Yeah, I tend to do that. All right, so let's fix it. If one side of a triangle is longer than another side, if one side of a triangle is longer than another side, then the angle opposite the longer side is greater than the angle opposite the other side. Thank you. Here's what that means. If we got a triangle, and we're going to call it ABC. This says if one side of a triangle is longer than another side. So let's make side CB like 12, and side AB, we'll make it 10. Do you see how we have one side that's longer than another side? What this rule says is that if this side, CB, is longer than side AB, then this angle A will be greater than this angle C. All right, so the measure of angle A will be greater than the measure of angle C. That makes sense to you guys? That look, you got angle A right here, right? Here's angle A. Here's angle A. Angle A had to open up so that this side is 12 units long, right? And angle C had to open up so that its opposite side was 10 units long. So which one had to open up further? Yeah, because the side opposite it is longer. Y'all understand that concept? If one door is open 2 feet and another door is open 3 feet, which door is open a larger angle? The door that's open 3 feet, right? Yeah, it's kind of common sense, but sometimes when it all happens in the same triangle, people start to get confused. So now the converse of this is also true. If an angle in a triangle is greater than another angle, then the side opposite is longer than the side opposite the other angle. If an angle in a triangle is greater than another angle, then the side opposite is longer than the side opposite the other angle. I guess that makes sense. Again, if you have this picture, we got triangle ABC, and let's say that angle C is 30 degrees and angle B is 20 degrees. Then wouldn't side AC, how does side AC compare to side AB? Less than, greater than, or equal to? You've got a side. Somebody play music or something like that? I can hear something playing. You better turn it off or leave. One. You see side AC right here? Isn't side AC opposite this 20-degree angle? And isn't side AB opposite this 30-degree angle? Everybody see that? So is AC less than or greater than AB? Isn't it less than? Isn't it going to be, isn't this open 20 degrees and this is open 30 degrees? So won't the side opposite be shorter than the side opposite? Right? It's like if one door is open 20 degrees and another door is open 30 degrees, which one is open less? The 20, isn't it? Y'all see that? All right, so now what we're going to do is I'm going to give you a triangle. ABC. I'm going to give you two of the angles. I'm going to ask you to order the sides by shortest to longest. Order the sides by or from shortest to longest. So if we're going to order the sides, the first thing we need is this third angle. Agreed? So if we got a 110 and a 40, what's this third angle got to be? 30. So now we need the shortest, the longest, and the middlest length side. Which side is the shortest in this picture? AC, good. And it's the shortest because it's across from the smallest angle, isn't it? 30 is opposite AC. What's the longest side? CB, good. Because it's opposite the largest angle. So what's left? AB. All right, because AB is opposite the 40-degree angle. That's how you're going to be using the rule. In its most basic form. Everybody caught up? All right, let's draw another triangle. Now we're going to order the angles from small to large. Order the angles from small to large. And I'm going to give you a side length and a side length. So what else do we need in order to order these small, medium, and large sides? Yes, sir.
You need either angle A or the measurement of line C.
Don't we need the length of CB? Okay. We know two of the sides, but we don't know what this third side is yet, right? So we got to find this third side. What kind of triangle is this? A right triangle. No, it would be 8 if AC was congruent to CB, but you don't know that. You know that it's a right triangle, and in a right triangle, A squared plus B squared equals C squared. So doesn't 8 squared plus CB squared equal 10 squared? Isn't that the Pythagorean theorem? That a one leg squared plus another leg squared equals the hypotenuse squared? We did that when we were using Pythagorean theorem instead of the distance formula. So look, 8 squared is 64 plus CB squared equals 100. So if we subtract 64 from each side, then CB squared equals 36. Now how do we get the exponent off that CB? Square root both sides. So if we square root both sides, the square root of CB squared is CB. And what's the square root of 36? 6. So we did all that to find out that C to B is equal to 6. So isn't CB the shortest side of this triangle? If CB is the shortest side of this triangle, what's the smallest angle in the triangle? Angle A, good. And if AB is 10 units long, then what is the largest angle in the triangle? Angle C, good. And what's left? Angle B. And it just so happens to be across from the side that's 8 units long, which is the middle length of the three. Everybody understand that? Any questions? Okay. Ready to keep writing? Or do you want to take a break and I'll give you like cookies and milk and take a little nap? And that ain't going to happen. All right. Real important rule. And this rule says that in a triangle, the range of values for the third side is between the difference and sum of the two shorter sides. In a triangle, the range of values for the third side is between the difference and sum of the two shorter sides. Here's what that means. One is, can you just pick any three lengths and make a triangle out of it? Some people are like, well, yeah, I can make a triangle at any three lengths. But think about this. I like drawing this picture right here. Think if this was like land, and don't draw this. You can't draw as good as me. If this was land and this was land, and, oh, this is good. I got all these colors. And this was water. Right? Back from my art teaching days. This is water. How would you get from one piece of land to the other piece of land? A bridge. Okay. We're not going to jump that far. We can't walk across water and we can't fly. So we're going to do a bridge. And back in the olden days, they did drawbridges, right? So they did a bridge. Now, you got this distance right here, agreed? And if we built this bridge and it went, let's say that it went like out to the middle. And it was going to be a drawbridge. Y'all know what that is? Drawbridge opens up on both sides. And then you had this other section of bridge on this side. And when that bridge opened, right, this went up to here and this went up to here. And then boats could pass underneath the bridge. It can't be longer because it would overlap, and it can't be shorter because it wouldn't touch, right? Right? See, if I gave you 3 pieces of wood, and I said, here's one piece of wood, okay? Here's another piece of wood, and here's the third piece of wood. Well, those 3 pieces of wood make a triangle. They're not. You can't have the leftovers on the end. No excess. Yeah, it ain't gonna work, is it? Oh my goodness! I'm trying to simplify this. Y'all are making it more difficult. That ain't gonna make a triangle right there. That picture, that's no triangle. No, it ain't gonna work. It's not gonna be a triangle. It ain't going to be a triangle. You're not going to cut the wood. You don't have a saw or any power. And you're not going to chew through it. Okay, never mind. Will the given, oh my goodness, will the given lengths form a triangle? I haven't given them to you yet. Will the given lengths form a triangle if I give you a 3 and a 12 and a 19? Will they form a triangle? Wrong again. We just said, you just wrote this down, that in a triangle, the range of values for the third side is between the difference and sum of the 2 shorter sides. The 2 shorter sides are 3 and 12. The difference of 3 and 12 is 9. The sum of 3 and 12 is 15. The third side needs to be less than 15 and greater than 9. Okay, so will this make a triangle? No. The third side's too long. If I give you the sides 6 and another 6 and 12, will that make a triangle?
Yes.
All right, what's the difference of the two shorter sides, 6 and 6? What's the difference?
0.
What's the sum?
12.
The third side has to be less than 12 and greater than 0. Is this less than 12 and greater than 0? No, it's not. It's equal to 12, so this won't make a triangle. This is explaining your quiz scores. This will not make a triangle either.
They're a little slow. A little. I did good. A bit more than good.
If you got a side that's 13 and a side that is 23 and a side that is 12,
No, it will. Yes, it will.
be quiet, please. Here's your two shorter sides. What's the difference in 13 and 12? What's the sum of 13 and 12? Your third side has to be greater than 1 and less than 25. So this works. Yes, it would make a triangle. Understand how it works if you're given all three sides. Stop, please, and pay attention. If you're given all three sides, you identify the two shorter sides. You subtract or you find the difference, and then you find the sum. The third side has to be between those, not including. Second part of this assignment, it will ask you to find the range of values. Find the range of values for the third side. Of a triangle. And what they're going to do is they're going to give you two sides. All right, so if you're given an 11 and a 14, your range of values, you're going to find the difference in 14 and 11. That's 3. You're going to find the sum of 14 and 11. That's 25. Your range of values for the third side, you got to be greater than 3 and you got to be less than 25. It's basically the same thing you did, but you're not given all three sides. You're given two of the sides and asked to find what the range of values would be for the third side. So if you're given a 1 and a 1 as two sides of the triangle, what's the difference of 1 and 1? 0. What's the sum of 1 and 1? 2. So the third side of that triangle has to be less than 2 and greater than 0. Understand? All right, your assignment for today, page 63, 1 through 10. Page 64, 9 through 17. And page 67, 1 through 16. And be sure that you check focus for homework. You guys that are in a Zoom meeting, I'm having problems on my end hearing you. So I need you to chat out. Send me your exit message via chat or any questions that you may have.
Are we
I'll
leaving
try to
right
answer them
now,
that way.
or are we staying in the Zoom call?
Otherwise, I'll see you tomorrow.